From the EPAWA headquarters in South Allentown, Pennsylvania, it's time for Weather Weeklies, an informative video of the ins and outs of weather that affect you most in the EPAWA coverage area. The following segment is a weekly video blog, and the opinions of the forecaster do not necessarily reflect the opinions of the staff of Eastern PA Weather Authority LLC as a whole, nor its constituents. Without further ado, here is meteorologist Bobby Martrus with Weather Weeklies.
And good Sunday morning to another edition of Weather Weeklies for December 20th. I'm starting to get out of a cold here. Had a little bit of laryngitis in the middle of the week here, so bear with me. I sound a little bit hoarse today, but definitely better than I have been. We always start off with the long-range forecast table here and the outlook. I'm not going to spend too much time on this, but the biggest thing is obviously below average this weekend, but after that, we're expecting temperatures to be above normal straight through January 6th in all of these periods. Now, it is going to get a little bit cooler toward the end of the period, get back to near normal. So near normal for January 3rd to January 6th. Normal, of course, is in the highs in the 30s. So this is not warm by any means. So we're going to be above normal here, 21st and 27th. We do have a cold front, especially warm up through Christmas Eve. Cold front comes through, and then we're going to get down a little bit. Temperatures are going to drop here Christmas and a couple days after that, but still remaining above normal. So that's why we have that period outlined for that. Another rain event here, 28th to the 29th. It looks like 28th or 29th to the 2nd, we start going near to slightly above normal. That's behind a cold front that's going to come through with that rain that we're expecting 28th, 29th. Once it goes through, it drops temperatures even more, and then another cold front comes through right around the 2nd or so, 2nd or 3rd, drops us back down to near normal. But we do think the pattern change is going to occur to where we get to a sustained colder pattern, and with that, with an active southern jet, we're going to get into cold and snow. Now, when is that actual pattern change? That has always been eluding us here. We were expecting the pattern change to happen a little bit sooner, but we did not. We figured out that there's other factors other than just what was showing us, what was being shown in the observations. We also are going to need help from the stratosphere. Okay, and I'll show you why here through this video here, but we do think that January temperature as a whole will result in slightly below average. Probably no snow in December here, we indicate that here, but January we do think snowfall gets to near normal, if not above. We'll have to examine that as we get a little bit closer. So let's look at the intraseasonal cycles here. This is a Madden-Julian oscillation. This is a measure of the convection, the greatest area of convection along the equator. This is the entire world on a flat piece of paper. Okay, so here, this is North America right here. Okay, this is South America right here. All right, over here is Africa right here, and this is Asia, India, South China Seas over here. This is where all your greatest convection is right now. This is a phase 5 signal, and I'll explain what all these phases mean here in a second. But here is also another area of convection here, right along the international date line, which is right here. Here's the international date line, 180 degrees. This area here was a result of the El Nino, the very warm temperatures out here that has been giving some forcing and convection, of course, being thunderstorms right along the international date line. That's just because the waters are so warm out here. But the greatest area of convection has been out here, and this is phase 5. You broke this down to where the phases are. Last week we were phase 3, phase 4, so your convection was out here in this area last week, and it is this eastward propagating convection. So it's moving eastward toward the date line. So we went from phase 3 to phase 4, now into phase 5. Okay, phase 6 would be the next step, phase 7, phase 8 near the date line, phase 1, phase 2, you get the picture. As soon as this continues eastward like this, once you get up in this area here, this is all favorable areas for a trough in the east. And why is that? If you look at this area here, this is what these thunderstorms do, the cluster of thunderstorms. They actually they throw heights at the ridge out west here. This will pump out the ridge out in this area here, allow for a trough in the Gulf of Alaska, a trough along the western coast of the United States, and a ridge in the east. Here's where we live, right here. We are on this warm side. If you're on a ridge, you're on a warm side. If you're on the trough, you're on the cold side here. And it's just like that, going back to trigonometry here, or those wavelengths, what goes up must come down. So having a ridge out here, everything else downstream is affected by that. So we're on the ridge and the warm side, and that's why we've had such warm weather. It has been like this for much of this month. And it looks like it's going to continue through the very end of the month before we see some changes here. Conversely, if that best convection is out in this area here, that is going to allow for a ridge into the Gulf of Alaska, ridge along the western half of the United States, along the coast, and then a trough in the east. That means we get into colder weather. So that's why you want the best force to be out in this area here. Okay, this is currently propagating eastward. It was south of India, now it's in the South China Sea. Okay, continuing to move eastward. Now, we look at the model projections. This is the European ensembles projection. So this is not the European operational. This is the ensembles as a blend of 51 members. Okay, this is where we were on Friday the 18th. Okay, this black dot represents where we were. Observed data. We were just barely exiting here, phase 4, heading into phase 5. And that's where we are right now. So we're at phase 5 today. And this is actually where we are right here. See, each of these dots here represent a different day. So that's today. This is Monday. This is Tuesday, Wednesday. See, we're getting these, see how it's going here? These dots are going. Eventually, you can follow the dots here, and it keeps going through until you get about the 29th or so. Follow the dots. And we finally get into these favorable phases over here in phase 7, phase 8. You can see where it's going. This is going to the more favorable phases. What do I mean by favorable phases? Okay, phase 4 is a warm phase. So is phase 5. So is phase 6. As we head into January, which is what we'll be doing here at this point when it gets to here, well, phase 7 is a cool phase. Not cold, but cool. Phase 8 is cold. Phase 1 is cold. Phase 2 is cold. And in January, phase 3 is cold. This is along the eastern half of the United States, okay? And you can see that here. Here's where we were last week, warm, phase 4. Here's where we are at phase 5. This is this week, warm. Phase 6, warm, very warm as a matter of fact, okay? That's phase 6, that's right here. Phase 7, we start going to cooler, but when we get into January, this gets even a cooler look than what's shown here, because this is a 3-month average, January, February, March. But in just January alone, phase 7 is a cooler signal here. All right, then it goes, that shows them going to phase 8, and you can see these blues here. The blues indicate cold. Phase 1 is cold, phase 2 is cold, and in January, phase 3 is cold. So it's heading in this direction, to the cold side, away from the warm, toward the cold. Okay? And, now I know this is just a model projection, but it's been consistently showing this. All right, that convection around the date line I showed you is a result of El Nino forcing, and that's because these water temperatures are so warm. The media is making a big deal about El Nino and how El Nino is making it so warm. I've seen several comments on the Facebook page about El Nino. Thanks to El Nino, that's the reason we're not getting any snow. That is false. That is completely false. You can put a big BS on that. I don't care what about this El Nino here. This El Nino right now, as a matter of fact, if you go to this, or the next frame here, this is showing what El Nino is doing over the last week here, last 7 days. Okay, El Nino is weakening, and you can see that by if it's increasing, it's going to be these colors up here. If it's decreasing, here's 0. Decreasing is going to be the blue. Eastern basins are rapidly weakening, and you can see that right here. In the past week, they have rapidly lowered temperatures here in the eastern regions. This makes sense with the trade winds, okay? It has maintained out here by the date line, out here in Nino 3.4, which is what we're really concerned about. This is Nino 3.4 right here, okay? That has maintained temperature. Eastern basins are weakening. So because they're doing that, because these temperatures are weakening, and you're going to have a more centralized or west centralized based El Nino, and that makes a big difference for cold in the east and a stormier pattern in the east. This is not a 97, 98 look, because the best warming was over here, and that made everything mild on the east coast. That's not happening. When you're going into, if you want a second half of winter that's going to be wild with cold and snow, you're going to need this area here to have the greatest warming, and that is continuing to show that. Okay? Again, El Nino is not running the pattern right now. Everybody thinks it is, but it's not. The real culprit here is the polar vortex. Polar vortex right now is a cold, dense air high in the atmosphere, normally centered around the polar region. Okay, and it is dead over the North Pole right now, and very, very strong. Okay, in order for us to get cold air back into the United States, when this is really cold like this, when this is really cold and it's locked up over the North Pole, the flow around it is just very fast like this, all the way around the globe. Okay, it means it can't. None of this can come down into the United States. We can't get the cold air to come down here because it's locked up here by the North Pole. In order for it to come down to the United States, and especially the eastern United States where we live, you need this to be displaced. The polar vortex that is up here in the North Pole needs to come down here and be displaced. What displaces it now? Well, in order to displace it, you need the stratospheric kelp. Okay, what is the stratosphere? A lot of people ask me that too. Well, what does that have to do with anything? We live in the troposphere. That's where all the weather happens. That is in the lower half. This is a model sounding I'm going to show you for point of reference. This is a look at temperatures as you go up through height, from all the way from the ground, which is 1,000 millibars right here. This is the ground level, and this is 50,000 feet in the atmosphere up here. When we're talking about the stratosphere in winter, that starts about 5 miles above the Earth. 5 miles is about 26,000 feet or so. So that's going to put your tropopause right about here. That's what separates the troposphere, where all the weather happens and where we live, from the upper atmosphere in the stratosphere. Okay, whatever happens to the stratosphere is exactly the opposite of what happens here. So in other words, as you go in the troposphere, as you go up through height here, the temperature decreases. When you go up in height in the stratosphere, the temperature increases. Okay, starts off very cold. All right, this blue line here, dark blue line here, represents the temperature as you go up in elevation. Okay, this is the 0 degrees Celsius line. Okay, so this temperature, since this line's going above here, down here at the surface, we are above 0, so we're warm. As you go up in height, though, it goes a lot colder, and we get to this point right here, where right here, this is showing this really cold temperatures right here. This is minus 30 degrees below 0 Celsius. Well, you see, as you go up in the stratosphere, it gets even colder yet. These are temperatures some 60 and 70 degrees below 0 Celsius as you get up in the stratosphere. But then you can see what it does. It starts to rise again. Okay, the temperatures start going back up as you get up to the upper stratosphere. Okay, so that's what the stratosphere is. Just want to show you where that is. It's the next layer above in the Earth's atmosphere. The polar vortex right now is very, very strong. Here is the polar vortex right now. Very strong. Okay? And you can see that right here. Here's a very strong polar vortex sitting right over the North Pole. What we need to have happen in order for this to displace is we need a sudden stratospheric warming episode. And we had one, really didn't do much. It helped weaken a little bit and moved it right back into position over the North Pole where it's once again very strong. And you can see that here. And it just barely weakened it. And then he moved forward, it went right back over the North Pole, got strong again. Now, we're going through another very big episode. This one is very, very strong. This is a very strong sudden stratospheric warming episode that will help displace this polar vortex and help to weaken the zonal winds. And this was also a what is known as a heat flux. This is a momentum flux, which will slow down the winds of the vortex itself. This will help to weaken it and displace it. And now right on its heels, you have another one. So the series of attacks that this is going under right now, under this polar vortex, will help to displace it. Here's what we're looking up in the stratosphere right now. This is going way up in the atmosphere again. This is where we are right now. North Pole is where it's sitting. It's sitting directly over the North Pole. North Pole is sitting right here. Here is your polar vortex. These are some very, very cold temperatures, minus 80 or below. Very cold temperatures. And it's very strong, sitting right over the North Pole. By doing that, see these winds here, they just go right around here like this. They can't come down to the lower layers of the atmosphere at all because they're locked up here over the North Pole. So what we need is this area here. This is the also in the stratosphere. This is a warming event, okay, that's starting now. All right, and this is what is projected to be in 10 days from now. You can see it's increasing here. This is actually working against this polar vortex to help weaken it and displace it. Now, it's not weakening a whole lot, but you can see now the center of focus is over here by Greenland. That's the center of this polar vortex, as opposed to being right directly over the North Pole. Now, it didn't move a whole lot, but that makes a big difference in some things, is now it allows some cold air to seep down here in the eastern United States. Okay, so this will happen, but it has a 2 to 3 week lag time, we think. 2 to 3 week lag time. So if you look at this date on here of when this sudden stratospheric warming episode is taking place, right around the 20th, 21st of December, right around the equinox. Okay, add 2 to 3 weeks of that, we have week 2 of January. Week 2 of January is when we think we feel the effects of that stratospheric warming episode. And of course, there's one right on its heels as well. Here's what the GFS ensemble shows for 15 days into the future here. And you can see the strong area of warming here. Strong area of warming displaces the polar vortex and elongates it. So the polar vortex is now over here instead of being directly over the North Pole. It's working against the polar vortex to weaken it and displace it. We don't need it to split necessarily. I know some people are saying think that this has to split, but it doesn't need to. It just needs to displace so that cold air can bleed down and we get a cross-polar flow and we can have some cold air bleed down in the eastern United States. This graphic on the right is the same image from 1958, January 1958. It was doing the same exact thing. The only problem is it didn't move this quickly. January 1958 was our number one analog to this winter. January 1958, we had the pattern flipped within the last few days of January. And that's because this process that's shown on the ensembles right now did not occur until the middle of the month. All right? Or the second week of January is when it started to occur, like this is starting to occur now. Okay, so we think that the second week of January is going to flip this year as opposed to January 1958, where it flipped at the end of the month. So we have a couple more weeks to add to the winter time frame here. Second week of January is when this would be flipping completely. All right, but this is very, very similar. Look at the positioning here of the warming and then the elongated PV here. Same thing, elongated PV here. Same thing happened in January. Okay, so this is very eerily similar to our number one analog. And what did that do in January 1958? Here's what we went from January, a very warm month, and 1958 ended near average, near to slightly below in our coverage area here because the flip did not occur at the end of the month. We think the flip's going to happen a little bit earlier, and we're getting to a snowier pattern a little bit sooner. So this could happen the second week of January. That's what we're projecting right now. Second week of January, based on the observational data. This is all observed right here, and the observed is showing it already starting. And the forecast in the short term is expected to be this very strong warming event that's going to lead to a displacement of the polar vortex. And that is the reason why we haven't been cold and we've been in a warmer pattern. Add into that the Madden-Julian Oscillation, this convection moving eastward and setting up a radar on the international date line. These two things in conjunction with one another, I think, is going to help the pattern flip. Now we are going to see a change here once we get to this point right here. We're getting into phase 7. This is around the 29th of December. So I do think we start seeing some changes where we're getting a little bit more favorable, get closer to average for this time of year. So there will be some snow chances right from the beginning of the month. We don't have to wait till the second week of January for that to happen necessarily. We're going to get into a colder pattern the first week, but I think it really starts to flip and get into more like a semi-permanent type structure of below normal temperatures as we head right through January, February, and at least the first half of March. And the reason we keep bringing up 1957, I want to go back to this map here because this is 1957 was when it flipped. If you go to February 1958, very, very cold in this area. Same thing with March, very, very cold. Okay. I'm going to use one point of reference in our coverage area. This is Allentown, Pennsylvania. Okay, it's probably the centermost point of our entire coverage area when you factor in all of eastern Pennsylvania, New Jersey, and Delaware that we cover. So we'll say Allentown, Pennsylvania is the centermost point. So we'll use that as an example. Up through January 31st, 1958, through the months of November, December, and January, there's a grand total of 12 inches of snow, exactly, 12.0, that fell up through January 31st, 1958. That's all there was. Okay, and we think we can get through the month of January and achieve that this year. Okay, after that point, from February 1st through the end of winter, an additional 51.6 inches of snow fell for a grand total of 63.6 for the entire winter and one of the snowiest on record. So it doesn't take much. Once this pattern flips and you get in that favorable, more favorable pattern, and you get some blocking like you did in 1958, we can have a pretty wild ride as we get into the second half of winter. So just exercise patience. That's why the only thing I can ask is that you exercise patience. I know everybody's hearing things from other sources. Everybody thinks they have the answers, and they want to bash the meteorologists and say, well, you guys called for snowy winter. So-and-so is saying it's going to be warm the rest of the year. I really don't care what so-and-so says. I'm looking at everything we're looking at here, and I'm showing you the reasons. Shows that everything is still progressing as planned. There's no reason to panic. Second week of January is what we're shooting for this pattern change. Okay? Sometime during the second week. That could be anywhere from the 8th to the 15th. It might be close to the 15th. It might be close to the 8th. We don't know that yet. Second week of January is when we flip, and then all this will be long forgotten. Remember, last year did this too. Last year started off warm in December, still had plenty of snow in the second half. This is going to be no different. I'm Eastern PA Weather Authority meteorologist Bobby Marchers. That is this edition of Weather Weeklies for December 20th, 2015. Have a great week. I'll see you again next week.